Hi there, my name is Eric Chiu, and this is a presentation on my senior capstone project, Maestro. This project is an exploration of procedural music generation. It also tries to answer the question, what's the difference between sound and music? The answer I came up with was invisible guidelines, in other words, music theory rules. I am going to briefly go over how I programmed music theory rules into code to generate music. The topics I am going to cover are modes, progressions, rhythm, structure, and melody. Modes in music theory is another name for a specific type of scale. There are 7 different modes: Ionian, Dorian, Phrygian, Lydian, Mixolydian, Aeolian, and Locrian. 2 of which you are probably familiar with already, the major and minor scale. The major scale is another name for the Ionian mode, and the minor scale is another name for the Aeolian mode. A scale is a series of half steps and whole steps on the piano. Notice that the order of half steps and whole steps remain the same between the modes. They are just shifted left and right along the scale. We can model this in computer programming through 7 different arrays. The number 2 represents a whole step, and the number 1 represents a half step. Now, no matter what key you start on, you can immediately determine the notes on a scale. Chord progressions is how you determine the order of chords played in a song. In this diagram, each number corresponds to the index of a note in a particular scale. This diagram shows the general paths used by composers to make chord progressions. This looks awfully similar to deterministic finite automatons in computer science, and in fact can be modeled as one in programming as a 2D array of probabilities. Rhythms determine the pattern of notes within a song. A typical time signature looks like this, where the top number represents the number of beats per measure. Here's an image of the most common time signatures. Looking at the top numbers, we notice that the most common time signatures is usually a factor of 12. Then we can make 12 empty spaces in an array for each measure and fill the spaces with notes depending on the rhythm. This is what 2 beats per measure would look like. This is what 3 beats per measure would look like. This is what 4 beats per measure would look like. And this is what 6 beats per measure would look like. The computer program can then read each index of the array at a certain time step to produce a rhythm. Structure in music theory determines how a song is arranged. There are 2 common types of song structures, binary and trinary. Binary would have an AABB pattern, and trinary would have an ABA pattern. The structure can go through several iterations, in a mix between binary and trinary patterns, resulting in complex musical structures. This is similar to the concept of L systems in computer graphics, and can be modeled as such in code. Finally, melody in music theory is a combination of notes and rhythm that produces a satisfying tune. We can use the chord notes selected through chord progression to pick which notes to play. This can be modeled using a Gaussian distribution toward the center of the piano, and a second Gaussian distribution toward the location of the hand. Combined, it produces a way of selecting particular notes. We can also select particular locations within the 12-space rhythm model to produce a unique rhythm on top of the harmony. Now that we went over the main music theory rules programmed into this project, let's take a look at the results. Overall, this project was a great way to utilize what I learned over 4 years in digital media design. It was a combination of computer science, computer graphics, art, and mathematics. And to top it off, I got a deeper understanding of music theory. Before I go, I want to say thank you to Norman Badler and Amy Calhoun for being amazing coordinators and advisors to the DMD program. Next, I want to thank Adam Malley for teaching me most of what I know in computer graphics. And finally, I want to thank my peers in DMD and CGDT for pushing and motivating me and making the impossible possible. I hope you enjoyed this presentation and look forward to seeing you again.